So we are taking a few more questions and answers in software engineering descriptive type questions. Explain the type of COCOMO models and give phase-wise distribution of effort. COCOMO, it stands for Constructive Cost Model. COCOMO. So it is an empirical based model which is on the project experiences, past project experiences. It is quite well documented and it is an independent model, not tied to any specific software vendor. And there is a long history for initial version published in 1981, COCOMO 81. And then we have various instantiations to COCOMO 2. COCOMO 2 takes into account different approaches to software development, reuse, etc. So this model gives three levels of estimation, namely the basic, the intermediate, and we have detailed. So basic COCOMO model, it gives an order of magnitude of cost. So this model uses the estimated size of software project and the type of software being developed. And the estimation varies for various type of projects. And this can be categorized into three different type of projects. First is organic, then we have semi-detached, and then we have the embedded model. So COCOMO, the basic model, divides the type of projects into three different projects. Organic mode, this project includes the relatively small teams working in a familiar environment and developing a well understood application. The feature of the project are like this: the communications overhead are low, the team members know what they can achieve, and this project is much common in nature. What about the semi-detached model? A project consists of mixed team of experience also and the new engineers, fresh engineers. The team has limited experience of related system development, and some of them may be unfamiliar with the output, also some aspects of system that are being developed. The embedded model, on the other hand, this will be very strong coupled hardware, software regulations and operational procedures, and the validation costs are very high. For example, the system program and development of say OCR, optical character recognition for English. Then we come to the intermediate COCOMO model. The intermediate COCOMO model estimates the software development effort by using 15 cost drivers. Variables beside the size variable used in basic COCOMO. Then in the detailed COCOMO model, the detailed COCOMO model can estimate the staffing cost, also duration of each of the development phases, the subsystems and the modules. And it will allow us to experiment with different development strategies to find the plan that will best suit your needs and resources, which is suiting your needs and resources. Differentiate between the function-oriented design and object-oriented design. So there are two types of major designs: function-oriented design and object-oriented design. In function-oriented design, in this strategy, it actually relies on decomposing the system into a set of interacting functions with a centralized system state shared by these all systems or functions. So functions may also maintain local state information, all of these, but only for a duration of their execution. The function-oriented design conceals the detail of the algorithm in a function, but system state information is not hidden. On the other hand, the object-oriented design transforms the analysis model created using the object-oriented analysis into a design model that would serve as a blueprint for the software coding, development, or construction. It is a design strategy which is based on information hiding. Object-oriented design is concerned with developing an object-oriented model of a software system to implement the identified requirements. So object-oriented design, it will establish a design blueprint that enables the software engineer to define the object-oriented architecture in a manner that would maximize the reuse. So it will help improving development speed and the end product quality. The object-oriented design with the function-oriented design. So unlike these function-oriented design methods, object-oriented design in this OOD, the basic abstractions are not real-world functions such as sort, display, track, etc., but real-world entities like employees, picture, machines. In object-oriented design, state information is not presented in a centralized shared memory, but it is actually distributed among the objects of the system. What is stepwise refinement? Discuss partitioning in abstraction. Stepwise refinement, it is a top-down design strategy originally proposed by Mr. Wirth, a program is developed by successive refining levels of procedural detail, and a hierarchy is developed by decomposing a macroscopic statement of function in a stepwise fashion until the programming language statements are reached. And refinement is actually a process of elaboration only. So we begin with a statement of function that is defined at high level abstraction. That is the statement that describes the function or information conceptually, but provides no information about the internal working of the function or the internal structure of the information. The refinement causes the designer to elaborate on the original statement, providing more and more details as each successive refinement would occur. Then the partitioning is done, so problems are often too large and complex that may be understood as a whole. So in this case, we tend to partition such system into parts that can be easily understood and establish interfaces between the parts so that the overall function can be accomplished. And this partitioning decomposes a problem into its part. We establish a hierarchical representation of the function or information and then partition the uppermost element by first exposing in increasing detail by moving vertically in the hierarchy or functionality decomposition, decomposing the problem by moving horizontally in the hierarchy. Then the abstraction. After decomposition, abstraction. Abstraction permits one to concentrate on the problem at some level of generalization and with regard to irrelevant low-level details. The use of abstraction also permits one to work with concepts and terms that are familiar in the problem domain or environment without having to transform them into the unfamiliar structure. So this abstraction, it allows considering the modules at the abstract level without worrying about its detail. And it provides external behavior of the modules, and it is used for existing modules as well as for modules that are being designed. It is essential for the problem partitioning also. Differentiate between the failures and the faults. Failure is the departure, you can say, of external results of programmer operations from requirement. So failure is something which is dynamic. So failure can also be defined as a deficiency in the performance, attribute, or excessive response time. And there are four general ways of characterizing failure occurrence in time. There is time of failure, time interval between failure, cumulative failures experienced up to a given time, and failure expressed in a time interval. So various failure classes are transient, permanent, recurable, unrecurable, non-corrupting, corrupting. In the reference to the fault is the defect in the program that when executed under certain condition or particular condition, it causes a failure. So fault is a property of the program rather than a property of its execution or behavior. So various fault classes are default, that is data faults, control faults, input-output faults, interface faults, storage management faults, and exception management faults. What do you understand by black box testing? In this, we have to explain the equivalence class and equivalence partitioning, because in these two things, they are the basic building block of black box testing. First, we do the equivalence partitioning, and then we do the boundary value analysis. In black box testing, this is also called as behavioral testing, functional testing. It focuses on the functional requirements of the software. So it enables the software engineer to derive sets of input conditions that will fully exercise all the functional requirements of a program. So it is a complementary approach that is likely to uncover the different class of errors that white box testing will also do. White box and black box, they have different kind of approach, and they uncover different type of errors. So black box testing attempts to find errors in these categories. First, incorrect or missing functions, interfacing errors, errors in the data structure or external data access, behavioral or performance errors, initialization and termination errors. So black box testing tend to be applied during the later stages of the testing, because black box testing purposely disregard the control structures. The attention is actually on the information domain. So we'll see the equivalence class, what it means. It represents a set of valid or invalid states for input condition. So an input condition is either a specific numeric value or a range of value or a set of related value or even a Boolean condition. Equivalence class may be defined according to these guidelines. If an input condition specifies a range, one valid and two invalid equivalence classes are defined. One valid, two invalid. If input condition requires a specific value, one valid and two invalid equivalence classes are defined. If input condition specifies a member of a set, one valid and one invalid equivalence class are defined. If an input condition is Boolean, one valid and one invalid class are defined. Equivalence partitioning. The equivalence partitioning is in the black box testing method. This will divide the input domain of a program into class of data which test cases can be derived. So an ideal test case single-handedly will uncover a class of errors that might otherwise require many classes to be executed before the general error can be observed. So equivalence partitioning strives to define test case that uncovers classes of errors, thereby reducing the total number of test cases that must be developed. Explain the reverse engineering and re-engineering. Reverse engineering, it is at the maintenance phase we generally do it. It is the process of analyzing software with a view to understand its design and specification. Analyzing software to understand the design and specification. So we have a source code and executable code as the input. So it may be part of re-engineering process, but may also be used to re-specify a system for re-implementation maybe. So it builds a program database and generates the information from this. So program understanding tools like browsers, cross-reference generates, etc. may be used in this process. So design and specification may be reverse engineered to serve as an input for SRS for say program replacement or be able to help the program maintenance. Reverse engineering often precedes the re-engineering, but is sometimes worthwhile in its own terms. The design and specification of a system may be reverse engineered so that they can be an input to the required specification problem for the system replacement. So the design and specification may be reverse engineered to support the program maintenance also. Re-engineering. What is re-engineering? It is reorganizing and modifying existing system to make them more maintainable. So it will need source code translation, reverse engineering, program structure development, program modularization, data re-engineering. So restructuring or rewriting part of all the legacy system without hanging its functionality or changing its functionality. So legacy system is a system that is hard to maintain. So it may involve redocumenting the system, organizing and restructuring the system, modifying and upgrading structure and value of the system data. Or input to a re-engineering process is a legacy system and output is a structured modularized version of the same program. So re-engineering involves adding effort to make them easier to maintain. So the system may be restructured or redocumented. So when to re-engineer? When the system changes are most confined to a part of the system, then re-engineer that part. When the hardware support, software support, they become obsolete. When tools to support restructuring are available. What are the advantages of re-engineering? We have reduced risk, reduced cost. That means there is high risk of new software development. There may be development problems, staffing problems, specification problems. What about the reduced cost? The cost of re-engineering is often significantly less than actually making a new software. So re-engineering cost factors would be the quality of the software to be re-engineered, the tool support available for re-engineering, and the extent of data conversion which is required, and the availability of expert staff for re-engineering. Explain various type of debugging techniques used in the software testing. Like the question is asking about there are various types like brute force, cost elimination, etc. So the debugging is the activity of locating and correcting errors, and we have various debugging techniques like code dumps. This is a printout of all registers and relevant memory location which is obtained and it is studied. All dumps should be well documented and it is retained for the possible use of subsequent problem. The advantage of this code dump is that the complete contents of memory at a crucial instance of time are obtained from study, and this can be cost effective if used to explore validity of a well formulated error hypothesis. The disadvantages: it requires some CPU time, significant input time, much analysis time, wasteful if used indiscriminately. And hexadecimal number are there which are quite cumbersome to interpret and difficult to determine the address of source language variables. The second idea is to take trace. Printouts contain only certain memory and register contents and printing in condition on some event which has occurred. So typical conditioning are say entry, exit or use of a particular subroutine, statement, macro or database, communication with terminal, print, disk or other peripheral. The value of the variable or expression, the timed actuations in certain real-time systems, or a special problem with trace programs is that the conditions are entered in a source language and any changes require a recompilation. Next is the print statements. The standard print statement is in the language being used sprinkled throughout the program to output values of key variables. The advantage is this is the simplest way to test whether a particular variable changes as it should after a particular event. A sequence of print statement portrays the dynamics of the variable which are changing. But the disadvantage is again cumbersome to use on large programs, and if you use it indiscriminately, they can produce copious data to be analyzed, much of which are actually superfluous. So debugging programs, this you can do. A program which runs concurrently with the program under test and provides commands to examine memory and register, stop execution for a program at a particular point, search for the references to a particular constant variables and registers. The advantage of this is terminal-oriented real-time programming is this. It provides considerable flexibility to examine the dynamics of operation. The disadvantage is generally works on machine language programs. So higher language versions must work with the interpreters, and most commonly used on microcomputers with large. Next question is explain the spiral model. So spiral model is one of the popular model used for large projects. So this model was proposed by Boehm in 1988, and it focuses on the minimizing the risk through the use of prototype. And we can view the spiral model as a waterfall model with each stage preceded by a risk analysis stage. So waterfall model, because prototype is also done. So at each this waterfall model is adopted, then one prototype is prepared, and again we analyze the risk. So the model is divided into 4 quadrants, each with a specific purpose, as it's showing in the figure. Each spiral represents the progress made in the project, and in the first quadrant, the objectives, alternative means to develop project, and constraints imposed on the projects are identified. The next quadrant deal with the identification of risk. As first is to identification of the objectives, alternative means to develop product and constraints. The second is the identification of risk and strategies to resolve the risk. The third bottom right quadrant follows the waterfall model, and in the bottom left quadrant, customer evaluates the product requirements that are further refined. So if at some stage during the project risk cannot be resolved, a project is then maybe terminated. So the model is used if the requirements are very complex and some new technology is being introduced by the company. And the advantages are the model tries to resolve all possible risk involved in the project. Each phase of the model improves the quality of the product. The disadvantages are the model is suitable only for large size projects because in some cases the cost of risk analysis may exceed the actual cost of the project, and expertise in risk management and project management is essential. This is the spiral model. Here we try to find out the constraints, the objectives, and we do the identification work here, any other option which is possible. Then we do the risk analysis here, and actually prototype is created like this. Prototype 1, prototype 2, prototype 3, prototype 4, like this. Then risk analysis is done here. The third quadrant is for engineering the product. That means the waterfall model is adopted here, and the product is actually prototype and created in the way of waterfall model. Then once it is prepared, the prototype is presented to the customer for evaluation, and these customer evaluation ideas and his inputs are there. They can be inputted, and then the planning for the next phase is done. So this is the spiral model. So thank you so much. This is all from the descriptive question series. Take care.